In this video, I'll talk about the additive rule. The probability of the union of events A and B is the sum of the probability of events A and B minus the probability of the intersection of the events A and B. Using our set logic notation, we write the probability of A in union with B is equal to the probability of A plus the probability of B minus the probability of A intersect B. So it is important that we remember to subtract the intersection of A and B. We must subtract this intersection because the sample point probabilities in the intersection have been included twice, once in the probability of A and once in the probability of B. In our first reference for classwork today, we're considering the following Venn diagram. You can see that in the Venn diagram, we already have our box, which represents the universe. S represents the sample space. And we have two circles, which means we have two events, event A and event B. In event A, we have 1, 2, 3, 4, 5 different points, and in event B, we have 4 different points. You might also notice that since these circles or these events are overlapping in this shaded region, we do have an intersection to consider. Back in problem 1, it says to consider the following Venn diagram, and it's telling us that points 2 and 3 are equally weighted, and that weight is 1/5. Point 4 and 5 are worth 1/20th. Point 6 is worth 1/10th, and point E7 is worth 1/5. So we could convert all of these fractions into decimals, and that might be easier since these fractions are not written with a common denominator. That would be our other option. We'll convert each of these fractions. So 1/5 really is 0.2, 1/20th is really 0.05, 1/10th is 0.1, and we have 1/5 repeating, so that's 0.2. And you'll notice that we only have points 2 through 7. E1 or 0.1 is not given, but we can calculate that. So if we take the decimal value for each of our data points and add it, we'll have 0.2, 4, 6, 7, and 0.8 is the total. So if 0.8 is the total and we have one missing piece, think about the complement. 1 minus 0.8 would give us 0.2. And this is the value for our first data point. Now that we have all the decimal values for our points, we can go back and find the following probabilities by first identifying the sample points in each. The probability of A means these 5 points are included in event A. So we'll simply add all of the decimal values representing these 5 points. So we found the value of E1, and we will take the probability of A would be E1, E2, E3, E5, and E6. So we'll add those decimals together. We end up with 0.75. So the probability of event A is equal to 0.75. Example B, we're looking for the probability of B. So event B involves E2, E3, E4, and E7. So using the values for those, you could either add the fractions 1/5 plus 1/5 plus 1/20th plus 1/5 to get 13/20ths, or using our decimal equivalents, we get 0.65. So the probability of event B is the decimal 0.65. If you take 13/20ths and do that division, you also end up with 0.65. For example C, notice the symbol given here. We are looking for the probability of A in union with B. So remember, union means A or B or both. So event A and B. Looking back, all of our points are in those two events. So we should end up with 1. Using the fractions, you end up with 20/20ths, which is 1. If we add up all of our decimals, we know that all of our points 2 through 7 added up to 0.8. So 0.8 added to 0.2 does equal 1. So whether we use decimals or fractions, Since every data point is within those events, it should add up to 1. We do not have any points out of the circles. With example D, we're looking for the probability of where A intersects B. So intersect means where both events are happening at the same time. And that would be here with E2 and E3. So using the fractions, 1/5 plus 1/5 isn't too bad because we already have a common denominator. That would make 2/5. Otherwise, with the decimal values, we would end up with 0.2 plus 0.2 equals 0.4, which is equivalent to 2/5. For example E, we're looking for the probability of the complement of A. That means all of the points that are not in event A. So that would be E4 and E7 only. So E4 and E7 are worth 1/20th plus 1/5. So there it's a little more complicated to find your common denominator first. It ends up to be 1/20th plus 4/20ths or 5/20ths. So we could go back and use our decimal values of 1/20th, which was our 0.05, added to 0.2, which is 0.25. And 0.25 is the same thing as 1/4. Next, we're looking for the probability of the complement of event B. So in other words, we're looking for all of the points that are not in event B. That would be E1, 5, and 6. So 1/5 plus 1/20th plus 1/10, translated in decimal form, we would have 0.2 plus 0.05 added to 0.1, which equals 0.35. Again, that is the same as 7/20ths. Event G says we're looking for the probability of A in union with the complement of A. So if you look at A in union with the complement of A, that means we want everything in A or everything not in A. So everything that is in A, that's points 1, 2, 3, 5, and 6. The complement of A would include 4 and 7. So actually we are looking for every point, the probability of every point, and that should add up to 1, and it does. Finally, for part H, we want the probability of the complement of A intersecting with the probability of event B. You might find it helpful to list everything that is the complement of A, and then list every point that is in B, and then we'll compare. So the complement of A would be E4 and E7. All of the points in event B, E2, 3, 4, and 7. So if we are looking for intersection, that means what is the same or what is in common with those two events. And if you write out your list, you'll see that E4 and E7 are the ones in common. So we're adding 1/20th plus 1/5, or we could add 0.05 to 0.2 to get 0.25, and that is the same as 5/20ths.